Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at combinations. So combinations are very similar to permutations, but the order doesn't matter here. So for combinations, we use this notation NCR, but we also use the notation N over R in brackets like that. These two both mean the same thing, they mean combinations. So if you are choosing R objects from a group of N and the order doesn't matter, the number of ways you can arrange them is this: N factorial over R factorial divide N minus R factorial. This part here is NPR, so NCR is just NPR divide R factorial. So I'm going to do this example here so that I can explain the difference between permutations and combinations. So let's say we're looking at two-letter arrangements from the word cat. So let's look at permutation. So the number of permutations, you're picking two objects from a group of three. So to be 3 factorial over 3 minus 2 factorial, which gives you 6. There are 6 two-letter arrangements of cat. We could take A and C, C and A and T, T and A, and then of course C and T, T and C. So these are the 6 possible permutations for two letters taken from the word cat. But what about for combinations? Well, it turns out for combinations, it's just 6 factorial NPR divided by R factorial. It's 6 divided by 2, which is 3. There are only 3 combinations. See, in combinations, it would say that these two are the same combination, these two are considered the same combination, and these two. So one combination would have an A and a C, one would have a T and an A, and one would have a T and a C. So when you're doing combinations and permutations questions, it's really important that you discern, is the order important? When we arrange the objects we've picked, do they have to be in order? If order matters, it's permutations, and if it doesn't matter, it's combinations. So let's look at some more examples of where order wouldn't matter. So here, from a class of 12 boys and 12 girls, 8 students are chosen at random. Calculate the probability first that at least one boy is picked, and secondly, the same number of boys and girls are picked. So here we're just picking 8 students. We weren't told that they have to be ranked first, second, third. That means that order doesn't matter. It's like if you're picking a team of 8 students to compete in a maths competition, it doesn't matter the order in which you pick them. So when order doesn't matter, we use combinations, and we're going to use combinations for this question. Now just remember, factorials, combinations, permutations, they're all counting tools. They're tools that just help us count many options very quickly, and we want to do that so we can use this formula for probability. Probability of an event is just number of ways it can occur over total number of outcomes, and combinations can help us calculate one or both of these things. So let's calculate the probability at least one boy is picked. So that means the probability that 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 boys are picked. That took a long time to say. It would take an even longer time to calculate. Remember that sometimes it's easier to calculate the probability an event doesn't happen. So what we're going to do here is we're going to calculate the probability of no boys, that's what I mean by 0B, and subtract it from 1. So how many combinations involve no boys? In other words, they involve all girls. Well, that's just going to be 12 choose 8. I'm using the bracket notation here. So you're picking 8 girls from 12. If there are no boys, that's how many there are in total. Now, what is the total number of ways that you can pick 8 students from a group of 24? Well, that is 24 choose 8. So the probability you pick no boys is this. So the probability you pick at least one boy, you just subtract from 1. And in most scientific calculators, you can put it straight on your calculator like that. You get about 0.999. And that makes sense. It's very, very likely you're going to pick at least one boy because it's very unlikely that all of the ones you pick would be girls. All right, let's calculate the probability the same number of boys and girls are picked. So we're going to use combinations to help us calculate the number of ways this can occur. So same number of boys and girls means we're picking 4 boys and 4 girls. So how many ways can you pick 4 boys? Well, you're picking 4 boys from a group of 12. Total number of ways this can occur is 12 choose 4. Similarly, the number of ways you can choose the 4 girls is 12 choose 4. Now we times them because they're groups. For each of these combinations, there is one of these combinations. So this is the total number of ways that you can pick 4 boys and 4 girls, and in probability means times. Once again, the total number of outcomes, you are picking 8 students from a group of 24. So this is the total number of possibilities. We don't need to subtract from 1 or anything. We're not using complementary events in this question. So putting that on our calculator, we get about 0.33. All right, let's now look at one harder example. So I roll a die 8 times, calculate the probability I roll a 6 exactly twice. So we're looking for the probability I get something like a 6 and then a 6, 2 6s, and then I have all of these not 6s. What would be the probability that you get 2 6s in a row and then 6 not 6s? Well, it would be 1 6 to the power of half times 5 over 6 to the power of 6. So remember that each roll of the die is independent. That's why we can multiply the probability of each roll together. So 1 over 6 is to the power of 2 is because there were 2 6s. 5 over 6 to the power of 6. So this is the probability you don't get a 6. This is the probability it happens 6 times in a row. But hang on a minute. If I want to know the probability I roll a 6 exactly twice, this isn't the only way it could occur. I could get 6 not 6s and then 2 6s. I could get 6 not 6, 6, and then the rest not 6s. It's getting hard to say, but how many such combinations will there be? How many ways can we have 2 6s and 6 not 6s? Well, think of it like this. There are 8 rolls in total, and we're looking at picking the 2 positions where the 6s would occur. So they could be 1st and 3rd, 2nd and 7th, 3rd and 6th, whatever it is, the total number of ways will be 8 choose 2. So combinations can help us here count how many ways this can occur. So for the final answer, I just put this straight in the calculator and we get about 0.26. So once again, combinations came to the rescue. They allowed us to count many possibilities very quickly. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.